So before we get started on today's lesson, we're going to look at problem number 1 on the worksheet. Let's see here. Let's do this right now. 27 degrees. There you go. So, guys, we're looking over the homework, problem number 1. Now, what we've worked with so far is sine and cosine. Now, sine of a given angle is the opposite side length over the hypotenuse. And cosine of a given angle is equal to the adjacent side length over the hypotenuse. Now, for the homework, we're really only solving for one side. We don't need to solve for both. And it's going to depend on what we're given, which one we use, sine or cosine. Now, we're given this angle here, 27 degrees. Now, x, the side we want to solve for, is the hypotenuse because it's opposite the right angle. That doesn't tell us much because sine and cosine both have the hypotenuse. Now, the other side that's given to us is the side length of 10. And is that adjacent or opposite the 27 degrees? Adjacent. So that means we're using cosine because cosine is adjacent over the hypotenuse. So we're saying cosine of our angle, 27 degrees, is equal to the adjacent side over the hypotenuse. So we get it set up. Now the first thing we need to do is multiply both sides by x, because here the x and x will cancel, telling us that x cosine of 27 degrees is equal to 10. Is the variable by itself? No. So at this point here, we would need to, yes, divide both sides by cosine of 27 degrees. And we do this here, cosine and cosine will cancel. Now in the calculator, we can do 10 divided by, or 10 over, cosine of 27 degrees. And hit enter. And we get 11.22. Or did I put 22? Fourth decimal, thank you. Yep, 2233. Yep. I think it says 4 decimal places. Yeah, so. Because if we look at the decimal after, so the 5th decimal place is the 6, so we round up. Yep, so we round to the nearest spot. So here, since the 5th one is a 6, it's closer to 3.3 than it is 3.2. I mean, we're just going 4 decimal places. It's going to depend on how it's set up, because if we were given, say, the opposite side, if we were given this value here, we can say is 14. It's not, but we would have sine would be 14 over x. Or if they gave us the hypotenuse as a number and the side as a variable, then it'd be the other way. Does that make sense? So it's mainly going to be based off of how it's set up, what we use. So sine, we're going to use it if we're given the hypotenuse and the opposite side length of the angle. Cosine, we'll be using it if we have the adjacent side and hypotenuse of the given angle. Does that make sense with those there? Well, out of all this here, so sine, if we have the opposite side and the hypotenuse, we can use it. With cosine, if we have the adjacent and hypotenuse, we would use it. Now, does that cover every type of option? No, what could we have? We could have the opposite and adjacent side and not the hypotenuse. If we have that, well, we'd have to try to go and find the hypotenuse to use sine and cosine. However, tangent is the ratio of the opposite side length over the adjacent side length. So tangent of a given angle is opposite over adjacent. Tangent is opposite over adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Yep. And that's why I don't play basketball. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent, the one we're looking at today, is opposite over adjacent. And thank you. So what we're going to look at first is writing tangent of the two angles in terms of their side lengths. So if we said tangent of S, again, tangent is opposite over adjacent. So the opposite side to angle S is 80. The adjacent side is 18. So tangent of S would be 80 over 18. And again, if we wanted in a decimal form rounded to 4 places, we can say 80 divided by 18, which is 4.4 repeated. 1, 2, 3, 4. Then we also need to find tangent of R. Now R is over here. Now what's the opposite side to angle R? And the adjacent side would be? So we have 18 over 80. 18 divided by 80 is 0.225. Almost, but this time the fractions are flipped. So the opposite and adjacent side flip depending on the angle. Because the opposite side for angle S is the adjacent side for angle R, and vice versa. Now, with sine and cosine, we kind of hit this yesterday. It was a weird way I interjected this in. With sine and cosine, because sine and cosine, the hypotenuse is on the bottom of the fraction, and the hypotenuse is always the biggest side. Sine and cosine can't have a value greater than 1. That's just how it works out, because the only way for them to have a value greater than 1 would mean that the adjacent or opposite side has to be bigger than the hypotenuse, which doesn't work. So they can't have a value greater than 1. However, with tangent, we're dealing with the two legs of the triangle, yes? Well, one of those can be bigger than the other. Most likely there are. There's only one case where they won't, and that case is when they're the same. But that means tangent can have a value greater than 1. So tangent's the only one where its value for either one of these here can actually be greater than 1. Questions on this here? So we want to find tangent of A and tangent of B. And we want to write them as fractions and decimals. Tangent of A. So what would the opposite side of angle A be? 15, and the adjacent side would be? Almost 36, because 39 would be the hypotenuse. So we'd have 15 over 36. which is going to be close to 1/2, but it's going to be a little bit less. 15 over 36.4167. Now we also want to find tangent of B. Tangent of angle B. So the opposite side is now 36 and the adjacent side is 15. Yes. Yeah, so for us here, it's mainly just going to be to point out the hypotenuse. They do have some values to them. Unfortunately, so if we look at tangent of 90 degrees, it's a domain error. So it doesn't help us much. Sine, let's throw that out, sine of 90 degrees is 1. So even if we have a value, it doesn't tell us anything, because if we think about solving, it means the hypotenuse, whatever its value is when multiplied by it, will just be the hypotenuse. It doesn't work for triangles. Cosine of 90 degrees is going to give us a value even more, not useless, but it's not going to help, especially with solving right triangles. The 90 is at 0. So that doesn't help us at all, if that makes sense. Yes. So sine of 90 is 1, cosine of 90 is 0. Now, before I move on to this next bit, are there any questions on this here? Now, this is a little bit above and beyond, but tangent, we said, of a given angle is the opposite side length over the adjacent, yes? What this works out to be the same as is sine over cosine. Tangent of an angle is the same as sine of that angle over cosine of that angle. Now, you don't have to just take my word for that there, because we said sine is what? Opposite side length over the hypotenuse. And we're saying this is over cosine, which is adjacent over the hypotenuse. That's just based off sine over cosine and how we have them set up. Now, whenever we have two fractions, really we're just saying that opposite over the hypotenuse is being divided by the adjacent side length over the hypotenuse. We don't divide two fractions. We keep the first one the same, change it from division to multiplication, and flip. When we multiply, the hypotenuse and hypotenuse would cancel out, leaving us with opposite over adjacent, which is our tangent. Now, when we said tangent, and I'm doing all this really to show you that when we said tangent of 90 degrees, how it gave us an error. Well, it's the same as what? Sine over cosine. Well, sine of 90 degrees we saw is cosine of 90 is, we can't divide by 0, so tangent at 90 degrees does not have a value. So there are some values that tangent doesn't actually have a value for, and it's units of 90. So 90, 180, or so, not that. It's 90, 270, and going in increments of 180 from there. Because tangent of 180 does have a value. It is 0. So there are some values that it does. Now, unfortunately, with right triangles, 90 doesn't help us much. So we get this here. Does that make sense? Now, any questions on how we write tangent for the two angles as a fraction or decimal? Do we feel comfortable with these here? Because normally writing these we feel pretty good with. We don't have to do a whole lot. of those. And if that's the case, we'll move on to these here. Solving for the given lengths. Find the value of x, round your answer to the nearest tenth. Now again, when we look at these here, especially with solving, we didn't do this so much with sine and cosine. I would look at the angle that we're given. So we can't use the right angle at all for these here because it's not really helpful as we just saw. But the angle that they did give us was 32. So that's the angle given. Now, we need to see what we're looking for and what side lengths, so what side lengths we're given and what we're solving. So according to the angle, we have the opposite and adjacent side, yes? So that means sine and cosine are not going to be helpful because both sine and cosine need the hypotenuse. We don't have it and we're not looking for it. So if we're not having it, if we don't have it and we're not looking for it, there's no reason to use it. So the only one that we can use is tangent, because tangent of 32 degrees is equal to the opposite side length, which is over the adjacent, which is x. Because if we'd been given the opposite side and the hypotenuse, we would use sine. If we were given the adjacent and the hypotenuse, we would use cosine. But here, we're given the opposite side and the adjacent, so we're going to use tangent. And again, the first main step with all these here is really going to multiply both sides by the bottom of the fraction. So here, it's x. Because here, x and x will cancel, telling us x tangent of 32 degrees is equal to 11. At this point here, we can check to make sure and see, is the variable by itself? Unfortunately, it's not. So that means we'll have to divide both sides by tangent of 32 degrees. And here, these will cancel. And again, at this point, we can plug this into a calculator. 11 over tangent of 32. 11 over tangent of 32 degrees is 17.6. That is it there. So this here, solving with tangent, isn't really any different than what we did yesterday. It's just based off how we're solving it, what sides we're given, plugging it in and solving. Questions on this here? So we want to find the value of x and round to the nearest tenth. So they gave us this angle of 25 degrees. Now, the three main sides of a triangle, especially with the right triangles that we have, are hypotenuse, opposite, and adjacent. Well, we're not given the hypotenuse. We're not trying to find the hypotenuse. So that means the only trig function we can actually use is tangent. And we say tangent of 25 degrees is equal to the opposite side. The opposite side, or the side farthest away from 25, is 12. And the adjacent side is x. Then we would multiply both sides by x. Yes. Because over here, the x and x would cancel, telling us that x times tangent of 25 is equal to 12. And then we would, yes, we would divide both sides by tangent of 25 degrees. Yes. This one only wants the tenth. Any questions on any of this here? Not too bad. We need to see another example of one of these here. really this is it. I'm going to look at this one here because this one here is a little bit nice. We'll look at it in two ways. But when we look at this one here, we're given 56 degrees. Now, since we're not solving for the hypotenuse, we're going to use tangent, which is opposite over adjacent. So we have x over 13. Now, this one works out a little bit nicer because we can multiply both sides by 13, which will tell me x is equal to 13 tangent of 56 is the variable by itself. Yeah. Since x is already by itself, we can just do 13 tangent of 56. 19.3. And that would be our answer. Now, again, I said I would look at this in two ways. Now, we know that this is a right triangle, yes? So these two angles here add up to be 90, yes? So if we subtracted 56 from 90, we would get 34. Another way I can look at this is tangent of 34 degrees is equal to, the opposite side is now 13, and the adjacent side would be x. Now we can multiply both sides by x. These here would cancel, telling me that x times tangent of 34 degrees is equal to 13. We got to divide because x is not by itself. So we'll divide both sides by tangent of 34. These here would cancel. And in the calculator, we can do 13 over tangent of 24 degrees. And what should we expect to get? The exact same thing, yes? Does it make sense how both of these work? Now, for the most part, probably, at least some of y'all said this to yourself, why would we do it again this way? This made it harder, didn't it? Let's look back at this one here. So this one here, we had to multiply and divide the kind of quote-unquote harder way, yes? If this is 25 degrees and these add up to be 90, yes? That means this one over here is 55, yes? So I could have said tangent of 55 degrees is equal to the opposite side length over the adjacent, yes? Multiply both sides by 12, telling me that x is equal to 12 times tangent of 55. $17.13. Make sure I did that right. Or am I doing 12? 12 tangent of. Make sure I did this right. Oh, that's why. 65. That's what I get for rushing. 12 tangent of 65. 25.73 or 25.7. Exact same thing. Either way, it still works. So if you don't want to go about finding the other angle, you can just use 25, do it the way that we've been doing it, and get it. Or you can get the other angle, do the exact same thing. Questions on this here? That's it.